So when we take our quiz, we'll review the rules that we've got so far. I mean, when we practice for our quiz. The quiz will not have the last transformation that we're going to talk about today. We're going to talk about absolute values today, how to graph those. That will not be on the quiz. The quiz is just over what we're talking about right now at this moment. Okay, so the quiz will look something like this. I'll give you some shape. And then I'm going to ask you to describe your changes in words and then to make the changes in a graph. Some of you have a hard time graphing them spatially, getting them situated right. So at least if you can tell me what you're trying to do, that will help. So here we are on our practice quiz. The original shape, it'll be, I'm not going to give you a complicated one like we had in our notes. It's a very, very basic shape. See how I ran it off on graph paper? So it's easy for you to count blocks and all that. The quiz is the same way. And the two problems are, the quiz will only have one. Oh, maybe I shouldn't say that. No, it might have two. I better not say that. It won't have more than two, I know that. All right, so these are the two problems. So let's describe in words what we're going to do to this problem. There are actually three things that are going to happen to this problem. So what is it? Let's describe it in words where it says list the changes. What are the changes we're going to make? Jill?
Down, two, flip, flip.
Okay, so it's going to flip upside down. All right.
Will we divide by 2?
No, we actually multiply the height by 2. Remember, a number out in front, this is one of the rules that you need to know for tomorrow's quiz. A number out in front, it's not always a 2, it could be anything. Any number out in front multiplies the height. So in this case, it happens to be a 2, so that's going to make the picture twice as tall, height, tall. All right, and there's one more change in this problem. Left 1. Now, this is what I mean by words. So somehow describe all the changes you're going to make. And now we're going to graph those changes. And how you do that is up to you. It's whatever works for you. I'm going to start by taking, where's your ID?
I just need my link.
Okay. So I'm gonna, wait, what was the original? I don't think I finished it. All right, so here was there's the original picture. Okay, so I'm gonna start by taking everything to the left 1. Okay, so I'm gonna just pick the whole thing up and move it 1 unit to the left. So that triangle just shifted over to here now. And this triangle shifted over to here. Does that make sense to you? You might not do it in this order, but did that make sense to you that I moved it 1 to the left? Now, I'm going to take that picture and I'm going to flip it upside down. So I'm simply going to take that point, and instead of going up 2, I'm going to go down 2 with it. And instead of going down 2 with that one, I'm going to go up 2 with it. Now I am able to erase. You are too if you use a pencil, but you don't have to, just use a colored pencil to indicate. That's my picture upside down. Now, what's the only thing left to do to it? Make it twice as tall. So that's like, pretend it's like a rubber band. You're pulling it, stretching it. So instead of being down 2, this is now gonna be down 4. It's not moving. Don't pick it up and move it. These points are still attached. It's just coming all the way down to 4. And then this one is going, these are still attached, going up to 4. So the blue, bless you,
Thank you.
the blue is the answer to the question. When you add, remember, that literally picks up the points and puts them down somewhere else. When you multiply, you're not moving it, you're just pulling it or smashing it, depending on what that number is.
Will you take off if we have like multiple lines on?
No, absolutely not, as long as I know which one is your final answer.
Okay.
So I suggest you have a colored pencil or a pen or something that maybe you outline your final answer. All right, there's one more. We ready for this? Ready for the next one? Everybody okay with this? All right, so the next one uses the same base picture, but it says f of negative x plus 1. All right, so let's describe the changes verbally with words. What are my changes? What's happening? This one only has 2.
Up 1,
2 changes. What?
up 1.
It's going up 1. This right here takes me up 1. Exactly right. So I'm gonna go back to my original picture and I'll lift it up 1.
It's flipping sideways.
And it's gonna do a sideways flip. This negative is different than this negative. This is a sideways flip. So on the quiz where it says changes, describe the changes in words, this is good enough. Up 1, sideways flip. That's good. You can write more if you want, but that's really all you need. That's what's happening. All right. So, here we go. Alright, I'm gonna start with the sideways flip. I think I told you yesterday, PEMDAS is like one of my life rules, and so I do what's in parentheses first. So that's a sideways flip. So, okay, so what does that mean? That means that this exact picture is now going to be over here. So that exact triangle is now over here. And then that guy is now over here. So that is the sideways flip. Now on the graph paper, to move it up 1 is super simple. Take this point right here and just go up 1 block. And then take this point and go up 1 block. Up 1 block, up 1 block, up 1 block. And connect the dots. And the blue thing is the answer to the question. So, break down the first problem again. This pretty much covers all the transformations that are on the quiz. Like I said, we're gonna learn one more today. But on the quiz, if the number is added or subtracted inside the parentheses, like this, what kind of movement is that? If it's added or subtracted inside the parentheses, that is a sideways shift, right? Left or right, pick it up and move it, left or right. Plus means left, minus means right. If the number is outside the parentheses, added or subtracted, that is a movement up and down. Plus is up, minus is down. If there's a negative, negatives always mean flips. So when you see a negative, you're gonna flip one way or the other. If the negative is out here in front, clear out here in front, then it's an upside down. If the negative is inside on the X, then it is sideways. Negatives are always flips. If you have a multiplication, so 2 times something, or 5 times something, or 1/3 times something, if it's a multiplication, not an add or subtract, but a multiplication, if the number is out here, it multiplies the height. And remember, if we're multiplying the height, that just means we're stretching it. We're not picking it up and moving it, we're just stretching it and making it taller. If the number, we don't have one up here, but if the number is a multiplication, but it's inside, see the difference? This number divides the width. So if this was my basic picture, and that's what I was graphing, I would take this same picture and divide the width by 2, so make it squishier. So instead of this triangle being over 2, 2 big, 2 wide across, now it would only be 1 wide across. And that one be the same height, but it would only be 2 across instead of 4. So that would be a picture of this. All right, those are the rules you need to know for tomorrow. Tomorrow's quiz, which is gonna look just like this. Okay?
So the 2 columns instead of 1, like.
I don't know, I haven't written it yet, so I'm not sure. It might be just like this. But those are the rules you need to know. Okay? All right. Okay. Now, get your notes out. We gotta finish up 1.6. There's one more change you need to learn. On the quiz, the figure will be easier. The figure will be like the one on the practice quiz. It'll be a real easy shape. All right, so here's our curve. We did some stuff with this one yesterday. This is the one that had a triangle, a semicircle, and a trapezoid. And today's lesson is all about absolute value. Ayrton? The quiz is gonna be run off on paper just like that one. Yep. All right, you ready? Okay. New rules. First of all, obviously you see the difference between these two problems. They both involve absolute value, but this one is the absolute value of the whole shebang, and And this one is just the absolute value of X. Okay, so that's, you gotta make that distinction. If it's the absolute value of the whole thing, the whole problem is an absolute value, I call this one bottoms up. Because when you graph it, you take anything on the bottom of the picture, and by bottom I mean underneath the x-axis, this is the bottom. Anything on the bottom gets folded up, it comes up. Anything that's already up just stays there. So this will be an easy picture to draw. My triangle is already up, so he stays there. My semicircle is already up, so he stays there. But my trapezoid is down and the bottom has to come up. So that would be the answer. To graph the absolute value of the whole picture, you just take whatever's on the bottom, whatever is underneath the x-axis, and fold it up. That's it. That's all there is to it. So remember, this is bottoms up. So the top stays fine and the bottom comes up. That's it. This one is more complicated, but still easy, but definitely more complicated. So when we have the absolute value of just X, two steps. First thing you do is draw the right side only. Okay, so the right side of my picture, starting here, right side of my picture. So I'm just gonna draw it. So I got my semicircle and my trapezoid. Notice I didn't change it, I just draw it exactly as it is. Alright, second step. Mirror right onto left. So what that means is, now take that and reflect it over, mirror it over. So draw that exact same shape mirrored over. So there and there. And that's the answer to the question. So we draw the right side and then fold it over and redraw it on the left side. Now, some of you are probably thinking, well, wait, Mrs. Ford, what happened to the triangle? Gone. It's gone. When you take the absolute value of just the x, whatever's on the right gets drawn on the left. And that's it. That's all there is to it. Okay? Now, that is not on your quiz, but it will be on your test. So we'll practice a little bit more. And then we'll go on. Anybody have a question about these before I erase them? We're going to practice a few more. Okay. All right, so let's look at problem C. And then we'll go ahead and do problem D. So we're putting some of our rules together. All right, here we go. What's this right here? What do I do with that? What transformation is that?
Anything on the bottom.
Exactly, that's bottoms up. And then what does this do? This part is on your quiz. What does this do?
Go up one.
Up one. So I'm gonna go ahead and do my bottoms up. And remember, what that means is the bottom comes up. So there's the bottoms up. Absolute value of the whole thing, the bottom part comes up. Now on your graph paper, it's super simple. To lift it up one, take each point up one. Or if you want to draw a geo squiggly line and do it that way, that's fine too, whatever. The blue has to be the answer that you end up with. Are we okay with that? You all right?
Yeah.
Now, what happens with this one, guys? What do I do here? Exactly. This says take the absolute value, which is bottoms up. So, okay, I'll draw that again. Okay, there's bottoms up. But what does a negative out in front do? Upside down. So this is your bottoms up, and this is upside down. So now, instead of the whole thing being on the top, the whole thing is going to be on the bottom. And again, the blue is the answer. And I'm okay with you leaving your black there. I'll go ahead and erase it, so it's more clear to you, but that's the answer. You're gonna do two more. Two more. All right. So there's E. Here is F. All right. What's this? Exactly, so it's draw right. I'll just say, if I just say mirror right, does everybody understand? Remember what I'm talking about? So we draw the right side of the picture exactly as it is. No, don't change it one bit. Draw the right side exactly. And then mirror that onto the left. Beautiful. What does this do? Down two. So again, on your graph paper, this should not be an issue for you. You're simply gonna take each point and count down 2 blocks. So you should end up with that blue thing right there. you're doing with graph paper, if you're out or want some more, grab another sheet here. If you're running low. some more graph paper. All right, so last one, here we go. What's happening with this? So we're gonna do the mirror right thing again. So I'll do that first. All right, there we go. So I've taken care of this. Now what does that do? That's on your quiz. This is on your quiz. What does that do? Multiplies the height. So that's a stretchy. That's a stretch, not a move. That's a stretch. This multiplies the height. So take the trapezoid and you leave it attached here, but you're going to stretch it so it's 2 times as tall. So how tall is it to start with? 1. So you're going to make it twice as tall. Kids, I gotta emphasize this. This 2 here, every single point moved. Every point moved. Here, the points aren't moving. You're grabbing a hold of the shape and pulling it down. Twice as tall on the circle. And then the same thing on the other side, obviously. So the blue thing would be the answer to the question.
So you just move every point twice down or whatever.
Okay,
Or up.
take the height of that figure is 1.
Yeah.
Double it. So now the height of that figure has to be 2.
I got you.
All right. We're gonna move on. I'm gonna take the last 10 minutes of class and we'll have you at the board because Kayla really wants to do some work at the board. He's volunteered. We'll practice a little more graphing at the board. Right now though, we are gonna move ahead in our notes. 1.6 is due on Friday. So you're able to do that right now and get it turned in. We know it all. All right, 1.7, here we go. Last section in this little unit, but it's a biggie. Yep, to all word problems. 1.7 is all word problems, which you are gonna be masters at. These are easy. So, number 1 says, just write an expression that says 6 more than twice the number. Okay, what do you think? 6 more than twice the number. 6 plus 2x. Now, do we have to use x?
No.
You can use anything you wanted, right? N, A, B, whatever letter you want. 6 more than 2 times the number, twice the number. That's easy. 6 less than 4 times the number. Now this one's a little bit tricky, be careful. 6 less than 4 times the number.
4x minus 6.
Very good, Edgenine. 4x minus 6. Because if we say 6 less than, doesn't that mean take away 6? Yeah, it doesn't mean 6 take away, it means take away 6. So 4x minus 6. Question? Somebody have a hand up like that? All right. 24% of a number. How do we write that? 24% of a number. What? How do you express 24%?
X times 24.
Bingo! 0.24. Guys, do you remember from your earlier lives that 24% as a decimal is 0.24?
Yeah.
Of in mathematics always means times. If you didn't already know that, kind of make a note. Whenever it says of, you're timesing. So 24% is 0.24. Of a number means times x. Perfect, perfect, perfect. The final cost of an item, if the original price is x, okay, there is a 15% discount and a 7% tax. All right, so a 15% discount and a 7% tax. Now, when you were freshmen, you did this exact kind of problem. We're gonna do a bunch of them because these are real life problems. But you did them in several steps. I don't know if you remember that. I remember distinctly working with some of you and doing these in step after step after step. There's an easier way. If we take the original price of the item and we want to get rid of 15%, a discount means you're taking it away, right? How much are we still paying? If we're taking away 15%, what percent are we still paying? 85? So I'm gonna multiply this by 0.85 because that represents 100 minus 15%. If you multiply by 0.15, that's telling you how much to take off. I really don't care how much is coming off. I want to know what I need to pay. If I'm losing 15%, then I'm keeping 85%. Now the same thing here for the tax. Are taxes coming off or getting added on? So this is going to be 100 plus 7% because it's getting added on to the 100. So what am I going to multiply there? 1.07? So what I want you to take away today is this is so much easier than what you did in the past. What I want you to take away is you don't ever really multiply by 15 or 7. You multiply by 100 minus 15 or 100 plus 7. So if it's a discount, it's 100 minus. If it's an add-on, like a tax or a tip or something like that, it's 100 plus. This would give you the answer to the question. So instead of having to multiply, subtract, multiply, add, you just type one thing into your calculator and that gives you the answer.
What happens if it costs more than $100?
What?
What if it costs more than $100?
No. These are percentages. This is 100% minus 15%. That will never change. This is the cost of the item. So if there's a 15% discount, no matter how much it costs, you're going to multiply by 0.85. And this is 100% plus 7%. Okay? So the percentages are never going to change because they're always based off of 100 to start with. The value, the dollar value may change. So this could be, I don't know, $28.75 or $2,562. This could be anything. And then a 15% discount and a 7% tax. Also could eat. Let's suppose the principal comes in and says, Mrs. Ford, I'm going to give you a 7% raise. So here's my salary right now, whatever that is. And they're going to give me a 7% raise. So what can I multiply by to do this in one step? Now, is a raise taking away or adding on? Adding on. So it's going to be my 100% plus a 7% raise. So what am I going to multiply by? 1.07. Now, suppose she came in and said, Ms. Ford, Kaylor says you're not entertaining me enough, So guess what? I'm gonna decrease your salary by 7%. If she decreases my salary by 7%, that's a takeaway, right? So what would I multiply by? 0.93, perfect. 100 minus 7%. So this would be a 7% raise, and this would be a 7% loss. Let's get down to H. We're gonna do the other two, but H kind of fits this. The final cost of an item whose original price is X, so I'm starting with X. We have a 20% discount, and we have a 7% tax. So what am I gonna multiply to do this in one step? What does a 20% discount look like? 100 minus 20, which is 80. So 100 minus 20, so multiply by 80%, multiply by 0.8. Then you gotta pay tax on it. So what does that look like? 1.07, because that's 100 plus 7. So if you walked in and you were gonna buy a shirt that costs $30, take out your phone, no, not really, but I mean at the store, multiply 30 times 0.8 times 1.07, and that's how much you're gonna pay for that shirt. Okay? All right, let's finish it up. F is a different, okay, F is a different kind of problem. So now we've got a rectangle. And what does it say about the rectangle? It says the width is 3 less than the length. So how do you want to set that up? The width is 3 less than the length. Any thoughts on that? Well, if I called the length X, what would the width be? If the width is 3 less than the length, what would this be? What is 3 less than? X minus 3. And then how do I find the area? The problem says find the area of the rectangle. How do we find the area? Length times width. Wouldn't that be it right there? Call one dimension X, and then define the other one, whatever the problem said. In this case, it said 3 less than. Find the perimeter of a rectangle whose length is twice the width. Okay, so here's my rectangle. The length is twice the width. So could I call this X? If I did, what would I call this? 2X. And this problem says find the perimeter. How do you find the perimeter? Add all of them up. So clearly if that's X, this is X, and this one's 2X, right? So the perimeters, just add them all up. So it looks like the answer is 6X. The perimeter would be 6X. Are you good? Yeah. Mm-hmm.
We have to give the answer, like simplify it.
You can't. I mean, this is, since they didn't tell you what the perimeter was, so in the next set of problems, starting with number 2, you're gonna actually have an equation to solve. But in all of these that we were just doing, we just wrote an expression. We didn't really have any ability to solve. So we're gonna do a couple more, and then we're gonna stop and do our little graphing practice for tomorrow's quiz. All right, here we go. 2A, your favorite teacher received a 3.2 salary increase. If her original salary is 1, 2, 3, 4, 5, find her new salary. Now I'm getting a 3.2% increase. So what am I going to multiply by? One number that I'm gonna multiply by that reflects a 3.2% increase.
97.
Well, it would be 96.8, I think. But would that add money onto my salary if I multiplied by 0.968? No, that would actually decrease it, wouldn't it? If I am adding on, don't I take 100 plus that? So, yep, 103.2, that's exactly right. That's the decimal for 103%. So then on our calculator, we just take 1, 2, 3, 4, 5 times 103.2. Excuse me, 1.032. I wish it were. If I had the right decimal there, I'd make over $1 million. That would be awesome. But it is not true. Oh my gosh. There we go. Did you get 12,740 and 4 cents? So the decimal I'm multiplying by is 103.2%, which is 1.032. And I typed in about 12 times. I think I finally got it right. Is that right? 12740.04. Last year, a Precal book cost $89.50. This year, it costs $97.75. Last problem today. Here we go. Let's get it done. Find the percent of increase. Now, this is a little different. Now we're finding the percent. Well, Mrs. Field taught you this too. Does anybody remember how to find percent of increase? Exactly. So it's the change or the difference. So that's a subtraction. It's the difference over the original. So he said subtract. Yes, indeed. So 97.75 minus 89.50. I'm going to figure out what that is. And then I'm going to divide it by the original. You might remember it as new minus old over old. It's the same thing. It's the change over the original. That's how we find the percent of change. So what'd you come up with? 97.75 minus 89.5 equals, divided by 89.5. Did you get about 9.2%? 9.22, 9.217, whatever. All right, we'll stop there and pick up with that next time. What I want to do now is give you an opportunity to practice your crafting a little bit more. All right, so Kayla, you're first up, buddy. Pick your partner. You and somebody else are coming to the board. You can pick whoever you want.
Anyone want to go up there with me? No? Alright guys, you guys all everything.
Don't give me a hard one like this.
I am. Just chill out.
Great.
Okay, now you guys are gonna graph, that's what you're gonna graph. You want a different one, Harrison? Alright, can we have another pair of volunteers then? We'll go ahead and graph another one. You flip it upside down and go left two. That's what he said, and he said it exactly right. That's exactly right. Okay, so you guys are gonna do this one. So, on the quiz tomorrow, you will be, describing in words. So Taylor's words were flip upside down and left
What
two.
graph you gonna do?
Alright, so. You guys wanna go to the board? You wanna go to the board? You guys go ahead and do Brennan's problem. Alright, Brennan and Edgeny
No.
in words, step aside so
You
you
go
can see.
next.
In words, what do you guys do?
We're drawing the original right now.
Okay. Yeah, you can write it now. So Edgeny says in words, they are flipping sideways, and what else are they doing? Up one.
This is the red.
Okay, so. Can you see the original? Let me draw it over here. This is the original picture that we worked with, okay? Alright, so, what does that do? Which way? Sideways, that's a sideways flip. So why don't you start with that? Take, this exact picture.
Good job.
Let's do it sideways, so this way. So you draw that on
Good
that
job.
side, or this on this side.
It's trash.
You're trash.
Talking about
Yeah.
that. He ain't do no type of work.
Where's the?
No type of work.
I put a no word?
No, he didn't.
Yeah, no, I did it all. So you didn't even pick up a
So
pencil.
that takes care of the sideways.
I did it all.
Everything is up one block, so it's harder on the block.
Before we get on it.
Everything goes up one. Everything goes up one. This comes up.
Hi, bro.
Really good thought.
I know.
That makes sense to you? All right. Okay, what is happening here? All right, I checked. The boys over there did great. And it matches what Brendan and Edgeny did perfectly beautiful. And then you guys, oh, wait.
What?
It depends on
Okay.
the location she gives you. So if you're
The, the upside down part is great, and the
two
two left part is great. Why is it stretched?
I did not structure
Okay, so does everybody understand my confusion here? We wouldn't do this unless we had a 2 out here in front.
Yeah, I didn't make the stretch.
Okay,
I just took it.
Oh, now you have to flip, oh, you have to
Upside
flip
down.
it because it's a negative.
so,
So, what the fuck did y'all do?
so
So
that
Oh, it's the same brand?
yeah, use the same
would
word.
look like this.
See,
Then
This
you're right,
one, so called.
then you're right,
and we have to flip sideways because
okay? All right, with that?
So how do you flip sideways?
All right.
Change to the opposite.
Good job, that's enough for the day, you guys did great, okay,
Oh, that's it?
Yeah.
that's it.
Oh, that's easy. I'm ready
Easy?
for